We're going to have a quiz on Tuesday. Yes! We're going to have a quiz on Tuesday on chapter 4. Right, so that's yeah, there we go. That's the right reaction. You want grades. You want more grades, many grades. So we'll have a quiz. We're going to write this. Not Monday, Tuesday, chapter 4. So that's the XP of X stuff. That's the binomial NPQ stuff, right? N choose X, so forth, and the mu equals NP. So we're going to finish the top of this. I think we finished this problem last time, the one about me finding my keys. Well, I'm pretty sure we finished that one. So we got to go back up, and this will be a nice little review of the binomial stuff. And the other part of the quiz will be the XP of X stuff. I'll have the formulas on the quiz. So we don't have to make a formula sheet. They'll just be on the quiz. I like it. You can read it because it'll be computer typed out instead of Jeff handwritten. It's always nice. All right, so let's take a look at this. Everybody has this now. It's the one that has this on the other side. Does anybody else need that? Okay. Anybody need to borrow a calculator before we get into this? Anyone need a calculator? Or a little key? Okay. Oh no, shit. Let's put him in the bad pile. That'll get you through the class. It's time to recharge. All right, guys, so let's do this first one kind of like as a review together. Read through this first problem. Hopefully you already have. And what can you summarize from what I tell you? There's 3 definite main variables to summarize for any binomial problem. I was about to give it away. Because I call the binomial problems a certain thing. What are the 3 things I need to know? N, P, Q. So I call binomial problems, I call them NPQ problems. Right? You can normally identify them pretty easily. I'll say something like 87% of something does something. If I take 28 of them, what's the probability? Okay, I could see N, I could see P, I can find Q. You should be able to identify them relatively easily. Right? So, what's N in this problem? 22. Yeah, you got 22 college students. So N is always the same thing. It's the total number I'm looking at. What's P? No. 0.68. So remember, P and Q, what are they physically? They are probabilities, right? Yeah. Probability of success, probability of failure. So they have to both be between 0 and 1, right? And they also have to add up to be 1. So if P is 0.68, what's Q got to be? 0.32. Craziness. Craziness. So don't write P as 68. That's what gets you in trouble. You'll start doing some probabilities and getting 3,000,000% chance of something, which is like, I don't even know what that is. So this is asking me the probability that X is 13, right? So how do I set up that formula? How many people do I have? 22, and I want to choose how many of them? 13. So how many successes do I have? It's very repetitive there, right? I like that. Choose 13 people, okay? To do what? To be successes, all right. And then how many are failures?
7.
Nope. 9. Why 9? Yeah, it's 22 total. If you put 13 of them in this box, then the other 9 got to go in that box. Yes? Yeah, I'm going to show you. You ready? Go ahead and take a minute, try it in the calculator, and then I'll do it to show you, in case you're having some issues. Are you you're mine. Okay, good. Full power. So let's see. The thing you got to be really careful about with this calculator, it's a bit of a trade-off. It looks exactly the way you write it on the screen, but that means you have to be a little careful as you put it in. What do I mean by that? 22. Where do I go to get shoes? Math.
3.
Probability. And then number 3 for the choose. I like it. And I want to choose, of course, 13. Where's my cursor at the moment? Down. For the next part, I better get the hell up, right? So I got to hit the over arrow to get back to normal. You guys get that? I'm going to have to do it again in a minute when I'm up in the exponent. You always got to make sure you come back to normal. Times 0.68 to the 13. Hit the over arrow to come back down. Times 0.32 to the 9. Let me stop for a minute. Anybody need me to do that again? You guys all right out there? All right, not seeing anybody requesting that. Do you guys get this? Oh, you guys, I love you. Yeah, don't give them anything. Yes?
Which kind do you have?
Oh, so it's a go-to. So what's beautiful is, do you go to? You have an extra, a whole extra thing. So you want times 0.68 to 13, and like an extra 2. Yeah, so when it says on the syntax go to, do go to, and then it puts a cursor on the problem. Yeah, just to show you what I was just telling him about. Let me make a mistake here. Syntax, right? Go to. Puts the cursor on the problem. I have some extra crap in here. Do you guys see that? So just got to delete this extra crap, and then I'm good. So if you have a go-to option on a syntax error, oh, it kicks ass. It's going to show you where the problem is. I like it. It's go to, not go coup. No Dragon Ball in this copy. Okay. So we got 0.1163. What does that mean exactly?
11.63%.
Chance to do what?
13.
Yeah, that 13 out of any random 22 will think that campus climate prevents them from talking freely. Okay, I like it. That's from an actual study, by the way. I don't know why I didn't put the little link like I normally do. So I don't know how you guys feel. Sometimes I feel like you think I don't let you speak, because you don't give me anything. I'm sorry. I'll get over it. What about Part B? Part B kind of sucks. You guys see the difference between Part A and Part B? Not just the fact that it's 21 instead of 13, but Part A was exactly 13. Part B is less than 21. Yes?
I got a question about Part B.
Sure.
Is it going to be similar how we say less than 0?
Or you mean at least 1 or something?
Yeah.
Yeah, it can't be less than 0, right? It's a good movie in song, but I know what you mean. It's going to be similar to that. Yes, it's going to be the exact same idea. So here we go. Why would doing less than 21 directly suck? What is less than 21? Not everything is not 21, because 22 is not 21. You see what I'm saying? I'm sorry, I'm just got to be a little bit. So less than 21 is 20, 19, 18, 17, all the way down to 0. You'd have to do a formula for each of those. Do you guys see what I'm saying? How can you be less than 21? You could be 20 or 19 or, so you have to do a formula and then add them all up all the way down to 0. Do you want to do that? And then I love it. Some of you guys are like, I don't want to do any of this. Okay, you're here, you better. I don't want to do all that shit either. So what's the opposite of less than 21 in this problem? 21 or 22. Would that be less work? Yes. So anytime the opposite probability requires less work than what they're asking me for, I'm going to do that shit. If I do that, I have the opposite of what they want. So then what do? 1 minus that. Anytime I have the opposite probability, I do 1 minus that. I really want you guys to get this. That question, too much work. Screw you question. I'm going to answer the opposite question, and then 1 minus that makes it answer that question. That's how opposite probabilities work. So the most general example, the thing that happens the most is the probability of at least 1 is 1 minus none. We've done that a shitload of times. Yes, maybe? No? Right? Okay. But the general idea behind that is the probability of something is 1 minus the probability of everything else. And if everything else is less, I'm going to do that. So, what do I need to do the formula for then? Well, the opposite of this, so the probability of x being less than 21 is 1 minus the probability that x equals 21 or 22. Yeah. Is the one that's got that on the side?
Yeah, I have that one. I just forgot it.
Oh, okay. So to do this, how do I do this piece right there? Let me put this word in there. Or, right? So I do the formula for 21. And then I add that to the formula for 22, because what does or mean? Add, yes. Right? So if I do 1 minus, let me see if you guys can handle this. Let me do this. What would it look like for 21, 22, choose 21? You with me? I'm just doing the formula for 21. 0.68 to the 21, 0.32 to the 1. Or 22, choose 22, 0.68 to the 22, 0.32 to the none. So all I've done there is the same thing we did in the first part. I'm just doing it for 21, 22. So if I do this, I get the opposite of what they want. And then I do 1 minus that. So go ahead and figure out what this plus this is. And you can put all this shit in the calculator at once. Blah, 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 plus. Blah, 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 blah. So what I do... I'm going to do a shortcut. See if you can get that for just adding those two up. So, yeah. You could put the whole formula in, but I'm pretty sure we talked about the fact, well, are you guys getting that same thing? When you add these together? So let me do it the full way out. I'll even go crazy and do that. I'll go crazy and do that. Get the same answer, of course I do. Okay. And then you just take, now here's what I can do on the calculator. 1 minus second negative. 1 minus the answer on the screen. Remember that ANS button that kicks ass? Bam. So at the end you should get 9977. One reason why you guys hate that is because it's not just the standard thing you always do. It's if the opposite situation has less work, I will do that. Right? So if I would have said, what's the probability that less than 3 think so? That would be 0, 1, 2. The opposite would be 3 up to 22. I ain't doing the opposite. That's got more work. Yes?
What would you do if something like a problem less than 15 out of 30?
I got you. Then it doesn't matter, does it? You just pick the way you want to do it. Then you would just do it directly, right? You wouldn't do the opposite. So sometimes they have the same amount of work. So then you go, all right, toss a coin to your witcher. Yes?
Why did you put it at the end of each problem, a 1 and a 0?
Oh, well, all right. So because officially, if there are 21 successes, how many failures must there be? Yeah. And then here there's all 22 successes, right? So then there's 0 failures. Yeah. The 2 exponents have to add up to be the total because that's how you're breaking the group up. Let that make complete physical sense. All right. So you guys do number 2. And remember, this is not a quiz. You can use your notes. You can use your handouts. You're going to need the formula for the mean and standard deviation, for example, right? Crap. Sorry, I got it. You guys watch The Witcher? Now it's in my head again. You're welcome. Hold that. Sorry. Stop. And you can always check with people near you too. I don't care, this ain't a quiz. Oh. Oh yeah.
That's 68% success. The rest has to be failures. 1 minus 0.68. And together they're supposed to make $1. And there's 68 cents there. There must be 32 cents there. So P is always 1 minus. Because together they have to.
I wrote 98.
Anybody else not get their quiz back? You get the quiz back?
Yeah.
Just make sure you guys are on the right track. Guys, what's the formula for the mean?
N times Q.
Good. And what's the formula for standard deviation?
N square root of N.
Kick ass. So you just got to throw that in, plug and chug.
Okay, so
How do I get min and max usual values? I start at the mean and I go, how many steps up, how many steps down? 2. So put the mean in the middle, whatever you get over there, and go up and down 2 steps. That's our official definition of where unusual starts. So it's related to, if I flip a coin 500 times, I expect to get 250 heads. But how far away from 250 would it be unusual? Would 260 heads be unusual? That doesn't feel like it. Would 300 heads be unusual? Probably. Now I'm getting kind of far away. So this formalizes that idea. We just use 2 standard deviations for right now.
Oh, so you're still down. So here's the problem. So much. So over 22. Choose. Where's this coming from? It should be 211.
what was it?
Standard deviation.
211. So make that 211.
I don't think it's.
Hit over.
I don't think
Back
it
there.
matters.
Yeah. Now, choose 19. No, it's choose 19.
You guys are just
19.
17.
Now, look at,
Yeah.
see how you're still down? Hit the over arrow. Now you're back up, times. Now be careful. Yeah, he's point 12, right, so point 12 to the, right, here's your to the 19. Now hit over to come back down. Times, point 88. What's 88 gonna be 2 then? If there's 19 here, and there's 211 total, what's gotta be here? 211 total, I put 19 over here, how many is left to go over there? You can even up it up here, watch, just allow it, put it there, right up yet, to the,
But you got
to 11,
Yeah, 25.
minus 19,
I just have.
oh, so it goes. Oh, 88. It's got a point in it. Oh. There.
All right, so this guy, 211, choose 19. So I got 19 successes, and the rest, what would that be? 192? I can subtract. All right, so if we put that in the old calculator, 211, choose 19. You guys get that? 0362? Yes, okay. And we're still doing probabilities out to 4 places. Today you'll really see why I do that. For the mean, it's just n times p. So what do you guys get for that?
25.32.
Kick ass. Standard deviation, square root of 211 times 0.12 times 0.88. Let me see. 4.72, oh yeah. All right, let me stop there for a minute. Those are the best, holy shit. We've had to make tables and do all this weird shit to find the mean and standard deviation. This one's like, nah, let's just do this. That's awesome. So if I put 25.32 in the middle and I go up 2 of these, so in the calculator I could do 25.32 plus 2 of means multiply these. So that's going to go up 2 standard deviations from the mean. Bam! And then I could do this. Second enter, make that a minus. Bam! So that goes from 15.88, become an 8, and then up to 34.76. Bless you. So anything in there would be usual. It wouldn't be something that would make me freak out. So if we found 14 workers out of some random group of 211, would that be unusual?
Yes.
That would be unusually low, right? So you've heard about unusually high occurrence of cancer in this one town or something. That's what they're investigating. That's exactly the math they're doing to see that that is unusual. Does it mean that it actually is something weird? No, because what's the chances? Anybody remember? What the probability is we're out there? 5%. 95% within 2, 5% outside of 2. So 5% is unusual, not impossible. So 14 workers would definitely be, yes, outside of 2 standard deviations. Or you can even just point over and say, here's 14. Right? That's the visual of what I just said. Outside of 2 steps. Kick ass. All right, good. So that one's done. We finished it. Yay! So those are the kind of questions I could ask you on the quiz, along with, of course, the X, P of X stuff. Okay. Yes? Why? Okay, let's do this. This is going to lead into the next thing anyway, so that's kind of nifty. Poor little dude. Trying to do what you can. There you go. All right. So what have I drawn up here? What kind of distribution does it look like I'm intending this to be? Normal. Bell curve, normal curve. 11. Can somebody figure out what these numbers might be? Show. No, okay. Z-scores. Z-scores tell me how far from the mean I am in standard deviations. The number of standard deviations from the mean to the data point. So in that case, if the Z-score is how far I am away from the mean in standard deviations, then what would the mean always become? How far away is the mean away from itself? 0. How far are you away from yourself? And don't say I astral project or some shit. You're 0 away from yourself. Right? So that's the mean. So then what would this be? That is the data point that is 1 standard deviation up. And that's 1 standard deviation down. I like it. So remember, I don't know if you guys remember this. Anybody remember what percentage is within 1 step? Yeah, 68%, kick ass. And of course, I just said a little while ago what percentage there is within 2. 95%. I like it. So why do we go 2 steps out and call that unusual? It is arbitrary to a point, but we had to agree on something just to get us started. And we thought if something had a less than 5% chance of happening, that sounds like a good thing to call unusual. Right? Yes? So that's why, because if there's 95% in here, how much is out here? 5%. So within 2 steps is what I usually expect to happen. So if these are heights, And heights of men and women are normally distributed. Very often, natural processes like growth, how tall you are, how heavy you are, whatever, those are going to be normally distributed. It's kind of nifty. So then I expect most of the people to be around the average height. When would you do a double take if you saw somebody who was 7'8"? Can you imagine 7'8"? Did I already tell you this story? Anybody know Manute Bol? Anybody remember that name? Well, what did Manute Bol do?
He was in
NBA. He was a basketball player. He was 7'7". I saw him when I went on a Southwest flight. I got off the flight and I saw this big crowd of people. And in the middle of the people, you could see Manute Bol's head because he's 7'7". So it's not impolite to do a double take because you don't see that. That would be unusual. So Manute Bol, his height would be up here. And, if I saw somebody who was 3'6", again, their height's way down there. I'm sorry, I don't see that all the time. I'm going to do a double take or something because I don't see that all the time. Are you guys with me? Okay, I like it. So does that answer the question from earlier? That's why we use 2 officially. Later this semester, I can't remember if I gave you this example. If I'm in a nuclear reactor and the little needle starts to move towards the yellow, right? I'm in the green and then it starts to move towards the yellow. Am I going to wait until that is 2 standard deviations away from normal to get off my... No. So in that case, I'm going to call unusual maybe half a step, not 2 steps. You guys understand what I'm saying? In different situations, we can actually redefine what unusual is, depending on how bad it would be if it actually meant something bad was happening. Does that make any sense? So right now, in general, we use 2 steps. When we get to chapter 9, I think it is, we're gonna change what that is based on the situation. All right, coming back to this. And I kind of pointed this out last time, but just to remind you guys, if I wanted to know the area of this, could I do it geometrically?
No.
I don't have any geometry equation that tells me trapezoid with a concave side. If you do, show me, right? If you know calculus, maybe you could. Okay, so we can't, but what I need then is I need some help. In chapter 5, we could calculate the areas of the rectangles. And that's the probability, right? Bam, beautiful, let that be nice. This chapter 6, I'm gonna need some frickin' help. My geometry dies, because it can't handle curvy sides unless it's a circle, and that ain't no circle, right?